Myself, Chetan. I am studying in Bangalore Institute of Technology, Bangalore. Well, I would like to thank my Professor Gunavati HS ma'am to give me the opportunity to do presentation and delivering few topics to you guys. So today my purpose is to tell you about the ROM and its applications. So why I took this topic for a discussion is so the ROM applications is quite different in the different ways because we can use the ROM as a ROM is used for storing the data. Permanent memory, we also know that it's the permanent memory. It's used to store the data. Along with that, ROM can be used to evaluate any given expression. This is the another application of ROM. So that's why I'm going to discuss how we use the ROM to implement any given expression. That's what my discussion in this PPT. So I'm not going to discuss about how the ROM is a permanent memory or not semi-permanent memory. That's not at all my topic. I'm just only concentrate on how we can use the ROM for implementing the any given expression. Okay, let's move. Okay, so firstly in this PPT we are going to explain about the introductions and architecture of ROM. Architecture in the sense what? So how we build the ROM to implement any given expressions. What are all the components required? What are all the things we need to give to solve the problems? And I will take one example as an expression so that we will get to know how we use the ROM. Okay, then different types of ROM. Finally, we are end up with the applications of ROM. So these are my blueprint of this PPT. I'm going to explain this in detail. Okay, so we come to the introduction to concept. So introduction. So ROM is an acronym for read only memory. So wait, I will take a pen. So ROM is an acronym for read only memory. That it's a memory which can stores the data. So basically these memories are used, as you know, basically these memories are used in computers, mobile phones, some other circuits to store the data. So it's a type of memory which can store the data permanently. So until it decline, it contains the same data as the manufacturer done. So that's the meaning of ROM. That's the special feature of ROM. And moreover, we cannot overwrite the data present in the ROM. But in RAM, we can programmable, we can overwrite, we can read, we can write. That's the special feature. This is the one special feature. So basically, these ROMs are used in storing the OS, storing the sample, small programs that need to that's are so much essential to operate any laptops or any program, any applications. So I'm not going to discuss much about the ROM, about the memory. I'll just concentrate on the implementation for my concern. Okay, so it's a non-volatile memory, as I told earlier. It's a non-volatile memory, and come to the ROM structure. So ROM structure in this ROM structure mainly consists of decoders and also the programmable or gates in the sense. So R gates, as you know that, so if any one of the input is high, then the output will be high. So we know that the basic thing of R gate. But in implementing the ROM, so ROM structure consists of arrays of R gates. Arrays of R gates in the sense, so we are using multiple R gates. So multiple R gates, and these R gates are programmable. So I think you will get so astonished what's the meaning of programmable. So I will explain. So programmable in the sense, so we are using multiple OR gates. So in multiple OR gates, each OR gates, we are not restricting them to have the same inputs. So it means if one OR gate has one input, then another OR gate may have one, two, three, like that. We are not going to restrict them to have the same inputs. That's the meaning of programmable OR gates. And in decoder, so we are well versed in decoder. We know the internal part of decoder, how it works, how it delivers the output. So it decodes the any binary code into information. Basically, information in the sense what min terms. So min terms are max terms in the given expression. So internal structure of decoder, as all you know, so it consists of some multiple AND gates where each AND gates have same inputs. So that's the meaning. Each AND gates have same, not same number of inputs. That's the meaning. So a AND gate is non-programmable, but OR gates which are used outside the decoder are programmable. So to evaluate any expression, we require these two components. Let's see. Other than this, we can also implement an expression using diodes, using transistors, so on. So let's see one by one. And in general, we can when come to the ROM as a memory, we can design several size of memories. So based on this expression 2 power x cross y, where x is the number of inputs and y is the number of outputs. So here x is an input that given to the decoder. So this is where n bits of information, or we can call it as n bits of address, that is placed on the decoder by the processor when it wants to read the data from the ROM. So the decoder decodes the given code into an information form. Select any one of the word line. So word line in the sense output of the decoder. So the selected word line consists of multiple called as M output lines. The M output lines are the bits of the word line, one word line. So the decoder selects any one of the word line, so the given according to the given input, then we can retrieve the data of that particular word line. So this is how ROM work. So let's see the architecture of ROM, how we implement how the ROM can be built to implement any given expressions. Let's see. So implementation of ROM, as I told earlier, there are three kinds of ROM implementation. One using decoders and OR gates, and one without using OR gates. We can also implement by using diodes and transistors also. So come to the first concept. So implementation of ROM and ROM. So we will discuss by using the truth table. Here the truth table are there. So actually I said earlier, my concern is only about how we utilize the ROM, how we can use the ROM to implement any given expression. Here F1, F2 are the expressions which having the following minterms 0 to 7. So zeroth minterm, first minterm, second minterms are at high state, and fifth and seventh also. Rest of them are at low state. So now I need to implement using the ROM. Okay, I'm going to use decoders and the OR gates. So to implement two expressions, any multiple expressions, if you want n number of expressions to be implemented using the ROM, so we can use m number of OR gates, so that we can connect the multiple inputs to the OR gate through the word line. Okay, so this is I used 3 to 8 decoder, where 3 is the 3 number of ABC are the number of inputs given to the decoder, which produces 8 minterms. So from M0 to M7, so it produces. If and also here you can see that the OR gates inputs are not same. Here in the F1 given expression OR gate is one OR gate which consists of 1, 2, 3, 4, 5 number of inputs, and F2 this OR gate which consists of 1, 2, 3 number of OR gates. So that by picture we came to know that in a ROM, so there are OR gates which we are not going to restrict the inputs of OR gates. Okay, now what I will do is, so I want to implement this expression F1. So F1, to implement this, M0 should be high, M1 should be high, M2 should be high, M5 should be high, M7 should be high. So that what we will do, so I just connect M0, M1, M2, M5, M7 to the OR gate, so that if any one of the word line is said to be high by the decoder, then my resultant output, my resultant expression will be high, so that I can satisfy the expression. So in the same way F2 also. So here F2 is having a minterms of M1 is high state, M4 is also high state, M6 is also high state. Rest of them are at a low state. So I just connect the M1 and M4 and M6 word lines to the OR gate, so that if three of them, any of three will be at high position, then I get a F2 as in at high position, high state, not high position, high state, so that I can implement these two expressions using ROM. So using decoders and OR gates also. So in detail I can tell. Okay, then another way of implementing a ROM for evaluation of expression is so using decoders and the diodes. So here we are not going to manipulate the things. So we are just as the diagrams showing that. So here just we are going to wait. I will explain using decoders and diodes. So here how the ROM store the data, how we can read the data. So here it is the internal structure of the ROM. So where we are using the diodes, so several diodes and also the NOT gate. Why the NOT gates are used? So here our decoder is active low decoder. Means active low means it produces an output which is at low state. Other rest of all output lines will be at high state. So that's why they mention the bubble here. So when if you consider there are four input lines, so that it consists of four. I think it's 4 to 8, 4 to 10 decoder. So if all the four bits are 00, then M0 should be at high position. But this is not in the case of low state decoder. So here M0 it is at low state. Rest of all the things should be at a high state. So this is the thing. This is the major key factor we need to note down. So let us assume that so it's internal part, so we cannot manipulate, we cannot rechange, we cannot reach in the these arrangements. It was done by the manufacturer itself. So that's why it called as permanent. We cannot reprogrammable it on. Okay. So here in M0 the diodes are connected to the word line. So these are called data lines. Okay, so the diode is acts like the characteristics of diode, as we know that it acts like a open switch when it is in reverse bias, acts like a closed switch when it is in forward bias. Okay, so first in build we are giving positive voltage to the anode and negative and cathode is connected to the word line. So based on the word line is whether high state or low state, so the diode behaves. So if my word line is at high state, so it becomes a reverse bias. So reverse bias in the sense what? So it acts like a closed switch. So the whole data line will consist of the 5 volt. So 5 volt in the sense in the logic we can say that is a logic high. When logic high is an input for a NOT gate, it reverse the input, so that logic 0 is the output. So when you want to get a 8-bit data, so we are using 8 NOT gates. So in this how we can also implement an expression as I mentioned earlier. Okay, the NAND gates are connected. If 0000 is the case, so M0 will be at a low state, rest of them all are at high state. So low state in the sense what? So this becomes cathode becomes at negative potential, anode in default it has a positive potential. So therefore diode is in forward bias, so it acts like a closed switch. Therefore M0 word line is connected to the data line. So throughout the data line consists of the which contains the information that is present in the word line, that is logic 0. When logic 0 is present, so is sent to the input of NOT gate, it reverses the logic and gives the output as logic 1. So D7 is the MCB of the data input. So D7 up to D0 to D7, which is at high state. In this way, so for if you consider 000, this D7, I think D6, D4, D3, D1, D0 will be at high position, and this D5 and D2 will be at low position. So in this way we can give the n bit of address, so that based on the address we are come across with the decoders and diodes. Using decoders and diodes we can design the ROM. So let's see how we can design the ROM using decoders and transistors. Using decoders and transistor, here we are using MOS transistor. So MOS transistor in the sense abbreviated as a metal oxide semiconductor transistor. So I will going to explain I will going to discuss two features about the MOS transistor. So MOS can be operated in several regions, as you know. So it is operated in the saturation region and cutoff region and activated region. So we can use the MOS transistor as a switch when we operate this transistor in the cutoff region. So we know that we are actually in our lower semester we studied that there are several characteristics, the output characteristics, transfer characteristics. So in that we are got to know that the MOS transistors can be used in several purpose by implement by in the cutoff regions, active region, what you call now. So in cutoff regions the MOS transistor can be used like a switch. So in cutoff region what happen, so MOS transistor, which consists of mainly, it's a field effect transistor. So your gate is the controlled terminal. So yeah, when gate is at low state, it means gate is at 0 volt. So MOS transistor acts like a open switch. When gate is at higher state, so MOS acts like a closed switch. Sorry. So here we can see that a manufacturer first while designing, he implemented every transistors. He connected every transistor to the every word line and data line. So as per the customer requirement, so he can store the data by removing the particular transistor, connecting the transistor. It's just like a diodes. So we are using the diodes in the previous slide. Here they are come up with the transistor, usage of transistor. That's all about architecture of decoders and architecture of ROM using decoders and MOS transistor. Let's see how my major concern is about how we implement any given expression using ROM. So let's see, let's jump to the topic that here evaluation of expressions using ROM. So this is my concern. So actually I explained so we are using there are three architectural designs we can use to evaluate any expression. So I just use the first architecture where decoders and arrays of OR gates are used. So let me consider this problem. Design a combination circuit using a ROM. The circuit accepts the 3-bit binary number and outputs a binary number equal to the square of the input number. First I am going to explain the problem. So here I am going to give a 3-bit number. So 3-bit in the sense, so it can take up to the value 0 to 8. So what is the expectation from my side from the combination circuit is I should get the square of the binary equivalent number. So whatever the input I give on, so for example if I give 0 0 as an input, if I give 0, I should get an output of 0. If I should give an input to 2, so binary equivalent of 2 is 0 1 0, so I should get an output of 4. So in terms of binary equivalent, so it is 1 0 0. So in that way my problem is asking me to design the implementing the expression using a ROM. So here you can see that from 0 to 8 I require since they are asking me to do 3-bit number, so A2, A1, A0 are the output inputs. So I need, in order to represent a square of the square of the 3-bit number, I should go up to 49, because 49, okay, just I will write. So 49, because my largest input 89. So to represent a 49 in a binary form, I require 6 bits. That's why I put it as the B5, B4, B3, B2, B1, B0. Okay, this is how truth table form. So whenever I give input 0 0 0, so my output will 0 0 0 0 0 1 0 0 0 1 0 1 0. I should expect 0 0 0 1 0 0, that is equivalent to 4. So whenever I give the binary number, whenever that number, when I give the any number, my output should be the square of that given number. So that's what the problem asking us to implement. Okay, so here we can see that just they consider only only the ROM of size 8 cross 4. So yeah, as I told earlier, 8 is representing the number of inputs, 4 is representing the number of output. Actually 8 is not number of inputs, it's 2 power x. So 2 power x in the sense what? To get a 8, x should be 3. Therefore 3 is my number of inputs, 4 is my number of output. So but I should get a 6-bit outputs. But here I consider the ROM of size only 4-bit. So it is so astonished, no? So but you can see that where every electronic practices, so every scientist, every designer is willing to do the circuits designing in a very simplified manner. So that's why here we can see that b1 is complete whole b1 bit is 0, so we can give the b1 directly to 0, and b0 is same as a0. So no need to connect, no need to extract this b0 and b1 from the ROM. So that we can reduce two output lines. So here you can see b0 is connected to the a0 and b1 is connected to the 0 state, and rest of the four outputs are taken from the 8 cross 4 ROM. So this is how we can implement the any given expression. Let's see, let us take one expression so that you will get to know how we can how we can implement further expressions using ROM. So let me take one example. Yeah, f of a b. These are all my three inputs. Okay, so I just consider the minterms of the this f expression. So let me take 0 1 2 3. So this is one expression. So if you want to implement multiple expressions using ROM, it is possible. So you can note that it is possible by using multiple OR gates. So that's why it is called as programmable OR gates. So where the inputs are not restricted to have the equal number of inputs. So we can get to know. So 2 wait. Okay, here I have 3 minterms and here I have 4 minterms. So I just consider the decoder of 3 is to 8. So actually I give only 3 inputs, right? So I need to consider 3 is to 8 decoder. It generates 8 minterms. Let me name this as B and C. Sorry, it is C. So let me write outline, what is called data line, sorry, word line. There are, I should write 8 word lines or 8 output lines. So it is 3 is to 8 decoder. So just named as 0 1 2 3 4 5 6 7. Okay, so let me draw the data line. This line is called data line. So since I mean, I'm going to implement two expressions, so I require two data lines and two OR gates also. So I'm not good at drawing, so please, I hope you are managing. Uh, okay, just extend these lines. Okay, so in given first expression f naught, so your minterms m0, m1, m2, m3 should be at high position, at high state, so that I can implement given expression. So whenever decoder, I just explained how the decoder works in the previous slides. So I'm just going to just connect. Yeah, this is called cross connections. So cross connections in the sense we can connect these. There are two different parts. So yeah, I should tell. So if I connect like this, if I connect data lines and word lines by using cross connection, it means that I can vary the input, the connections is not fixed. So I can remove this, I can add some upon, I can remove this. But when we connect data lines and word lines like this, dotted lines, dotted mark, it means it is fixed. So it is, we cannot remove the connections, we cannot manipulate the connections, it is fixed. But here it is hollow. So that's why, since it is a programmable, I'm thinking to implement several expressions, so that I just connect through cross connections. So 1 2 3, I hope 0 1 2, and this is 3. Okay, so this is 2, sorry, this is 2 4, and this is 6. This is f naught, this is f1. So in this way we can implement any given expressions using the array of OR gates and decoders. Nothing but it's just like a ROM. So it's simply, it is a ROM. It is a ROM. Hope so you are getting the concept. Next, so it is PROM. Just came to know that different types of ROM can be designed. So what's the main purpose of designing different types of ROM is we can rewrite the data present in the ROM. So that's the main application of different types of ROM. So as of now, they are discovered several types. So one EEROM, flash memory and mask memory. So here PROM stands for ROM, EPROM stands for erasable programmable ROM, EEPROM stands for electrically erasable programmable ROM, and flash memory and mask ROM. So it's also known as flash EPROM. So flash EPROM. So there's a different characteristics between EPROM and flash EPROM. So let us discuss one by one. So this PROM is programmable ROM. So here we can program the ROM only at once. So once you program, next for the next we can't program the ROM. So that is the main feature where the contents can be changed only at once. So this is the special feature of PROM. So in this designer, what he goes, so let me consider a ROM which has some details in the which have some data. So if I want to rewrite the data, so I just where we come across with a various type of architecture of ROM, right? So diodes using transistor. So which diode is connected to data line, so it will produce a output. So if I need to change that output, I'm just going to fuse that circuits, fuse that component, so that I will disconnect the connection between word line and data line. So this is how PROM can be manufactured using the ROMs only. So it allows users to only rewrite the data at only once. Then EPROM. EPROM is nothing but erasable programmable ROM. So erasable programmable ROM. So this type of ROM allows the users to erase the data present in the ROM, and moreover we can program the data. So the erase in the 19th century, there's a scientists were came to know that so transistors have the characteristics of holding the charges. So that if it hold it, it means it is a zero potential. If it is if does not have a charges in the transistor, it means it is a one state, logic 1 logic 0, so like that they are considered. So if you want to erase the data present in the EPROM to the UV light, so that electric charges present in the transistor absorbs the UV radiations, absorbs the energy, they get exhaust what you call energized and emitted from the transistor. So in this how we can change the states of the transistor. Meanwhile we can change the data. So and moreover we can program the data by supplying the electric charges. So in this how EPROM works. EEROMs is nothing but, so it's an advanced version of, we can say advanced version of EPROM. So where erasable process is done through UV rays in the EPROM, but in EEROM, so it is done through the electrically, that's why it's named as electrically erasable ROM. So we can erase the data using electric signals, electric currents, so electric voltages we can erase. When so this electrical EEROM erases the data bit by bit. So that's the one key factor of EEROM. So flash memory is the special type of EEROM where I just want to erase overall word or over page of data. So in that case I use flash memory. Mask memory is just a type of PROM, so where the designer only store the data, whatever the data required. So the just implement the data, not manipulate the data present in the ROM. So these are all the different types of ROM. Let me explain. Let me discuss few applications of ROM other than storing the data. Other than actually the main purpose of ROM is only storage of data, storage of information, storage of programs. So let us discuss how it works. So application of ROM. So in application, so it's main, as you know, user to store the data, and in some case it's used to store the firmware softwares. So and boot camp memory, data tables, so data converters and function generators also. So these are all the following applications of the ROM. So yeah, the one interesting topic is the firmware. So firmware, it's a software program. So as you it's a software program. One thing is a specific class of computer program where level control. Yeah, that low level control. Yeah. So low level control for a device's specific hardware in the sense. So computer consists of several hardwares. So in order to interact with the different devices, the designer or the manufacturer software, so low level software, it's a low level software just in order to communicate between the devices, between the device. So that's why it's a firmware. So it provides necessary instruction for how the device communicate with other device. So in the NEP, so there is firmware is nothing but it's a software program. So where it has the instructions that tells the devices to communicate with other. So along with the usage in the laptop and mobile phone, it's also used in the traffic lights and consumer appliances. Consumer appliances in the sense what we can see the firmware software in the remote buttons were used in the where we used to operate the TVs or microphones or AC like that. So on digital watches we can also use the firmware. So this all about the firmware and its where we are using. So this is a brief introduction about the applications of firmware. So actually, this is not my concern. This is not my topic to discuss the applications of ROM. So my aim is to tell you people about the how we use the ROM to implement any given expressions and architectures of ROMs. So this is my presentations. I hope you can you are understand well. Thank you for being with me. Thank you. Keep supporting me. Thank you guys.